Hi, I'm Garrett with IDC Woodcraft, and I'd like to welcome you to this video. If you have a CNC router and you make signs with it that need to hang on the wall, and you need to learn how to make T-slots like that, then that's what you're going to learn in this video today. I'm going to teach you exactly how to design this up and how to generate the toolpath for it, and I'm going to teach you how to get the Tslot cutter into your tool library. You have to get this set up in a separate way. If you don't do it right, you are going to have problems if you try to do this without doing what I am going to be teaching you. And then we're going to take the project and we're going to slap it on the router, and I'll show you how to set it up like that. Now, I've got a couple bonuses in this video that's going to help you out a lot. The first one is I'm going to give you the G code for this T-slot. Basically, T-slots, they run like a lot faster than it ever takes to design them up and set them up. They're so quick, I figured I just might as well give it to you. That the thing is the G code that I'm giving you, you have to take a look at later on in this video. You have to set it up exactly the way I set it up. Otherwise, you might have some problems. So I have to make a disclaimer, you are responsible if you use that G code. And I'm also going to be teaching you about the GCenter software. There's not a lot of videos out there, so I figure I'm going to be using it, and I'm going to teach you along the way about the GCenter software. It's got so many features that none of the other control softwares have out there. It's a dream to work with. Links for everything I talk about will be down in the description, including this bit and the GCenter software, the long mill, which I totally endorse. If you haven't seen the review video where I am standing on that thing while it's running, you got to go check it out. I'll leave a link for that down below too. And I think that's about it. You're going to get a lot of tips in this video. So the first thing we're going to do is talk about the bit itself, and particularly this bit, which is not the highest quality bit, but unfortunately there is no middle of the road Tslot cutter. So I am actually working to get one sourced. It's either $150 for a Tslot cutter or it's $10 for a set of 3. That should tell you something. All right, let's start talking about the cutter, and then we'll move on from there. Now, there are a lot of different types of Tslot cutters, but for all intents and purposes, we are doing everything with this style here. This came as a set of 3 off of Amazon, and they are ultra cheap, like $10 for the set of 3. They're not high quality cutters whatsoever. These are what I consider throwaway bits. So what you'll notice when you do these, it'll cut a little bit rough. It'll just sound rough. However, if you want to step it up a notch, you're going to be spending $100 or more. So because these are so difficult to find, I am actually talking to my supplier now to actually design these up. Here's the style of this bit. You can see that there are 2 flutes on this bit. There's a flute over here and a flute over on this side. And there are 2 cutting diameters. We have the bottom of the slot, or the wide part of the slot right here, and then we have the upper part of the slot right here. And this is what the slot will look like when it makes this cut. This is considered a cross section of your material, so the scribble area is your material, and that's the T-slot that's been cut out by this bit right here. So it comes down at some point, plunges down to the material, then drives across or cuts across the material, and then it's going to come back and pull out. And that's the way we're going to design it. But also this is the way this project looks. So what I want to make sure of when you are doing projects like this is this depth from here to here cannot exceed the overall depth of the cutting blades. So you want to make sure that if your cutting blades are, let's say, 1/2 of an inch, let's just measure this one up and see what this is. We are roughly right there. So that's 10 millimeters or 0.42 inches. So we don't ever want to go past 0.4 inches. This one I always set to 3/8 of an inch deep, or 0.375. That would be about 9 millimeters deep. So that's what we're going to be creating. Now, if you look at it from the top view of your material, you are going to end up seeing something like this, just like we showed you on that piece of wood. So the bit will come down here, it'll go across there, and then it'll come back and pull back out. Okay, so we're going to drive into the Vectric software and we're going to design it up. It's super easy. And then we're going to get into the G code, and then I am going to tell you how to get hold of the G code, and you'll know exactly how to set this up from there. We are in Vectric, and I just want to remind you, this will work in all variants of the Vectric software, the 2D, the Pro, Desktop, Aspire. As far as other softwares go, like Easel, Carbide, Create, I honestly don't know. However, the G-code file that you will be able to download, you can work with that and adjust it the way I tell you. With that G-code file, I'm going to tell you up front, do not download it until you understand what I talk to you about later on and some of the cautions I want you to take. Alright, so let's design our slot. So essentially the way we're going to design our slot is we are going to design it off the middle of a 0 point. For all intents and purposes, we're going to create a 0 point on our project, or a crosshair. And that crosshair may be up here on the project. But for the intents of this software, we need to make it where our XY0 meets or intersects. So when you're setting your project up, you want to make sure that you are set up with your XY datum position in the middle. Now this project is 24 by 24 by 3/4 of an inch. It doesn't really matter. That's just what I have it set at. Your sign may be any size. It doesn't matter. Use this method to make it as simple as possible. Okay, so let's just say we want a slot that's going to be 2 inches long. What we're going to do is grab a polyline. That's this tool right here under Create Vectors. It's the one that looks like a little zigzag. And we're going to select that. And that's going to put us into draw a straight line mode. Now before we draw anything, we want to make sure our snaps are turned on. Just turn both of them on. And we are just going to let it snap to the horizontal line. You see my cursor. Watch it. It has a little plus and a zigzag and some numbers. And when I get to the line, it's going to change into a bullseye. That means we are snapping to that horizontal line. So while we have the bullseye, click your left mouse button once, and now it has grabbed a point. And then we are simply going to pull straight across while that line is straight. You don't want it like that. You want this to be snapped onto the line. So you see my cursor again has that crosshair. You want that crosshair to be there. On our keyboard, we're going to type in 2 and then enter. And what we just did is we created a 2-inch line. Now we're going to zoom in a little bit to this line, and we are going to move backward to the other one. And it's going to turn into, you're going to see, we're going to get changes in our cursor. What we want it to do is, first of all, you see just above my cursor, that line has a little black spot on it. That means it's snapped to the reference of the end of that line. So you can see I have a dashed line there. So that dot indicates that we are perpendicular to that line right now. Wherever we click, we are going to be on that dashed line. But what we want to do is be all the way on the line there. So we want to turn back into a bullseye, and we're simply going to click right over that. The other way you can do this is just come back over it, type in 2 again, and enter, and now our line has come back. Now you'll notice something, that the software by default stopped drawing a line. What we have is basically we have a line that's drawn over top of itself. And Vectric for some reason just quits at that point when you do that, which is okay because that's exactly where we want it to quit. So now we're going to close this box, and we're going to come from the upper right or lower right, and we're going to hold our left mouse button down and just create a window so we can drag across that line and let it go. So you see now that that line has been highlighted. What we want to do now is center that line on the 0 point. Very simple to do. You go under Transform Objects and select the last icon which is align selected objects, and then pick the upper middle one right there, which aligns it to the center of both up and down of the project. So we click that, and the line has now moved over into position. Close that. And our T-slot line design is complete. It's that simple. I'm going to run through this one more time. So what we're going to do is just delete that. Right now you see it's highlighted purple. I'm just going to hit the delete button to eliminate it. And I'm going to do it a little bit differently this time. We're going to grab that polyline again. We're just going to come somewhere here in the middle, and we are going to snap with our left mouse button. And we're going to come across so we have that dashed line that goes all the way through the line and goes off to both sides and ends of the screen. And we're just going to come over that way. We're going to hit 2 and enter, and then we're going to come back the other way, and you can see both. There's a dot here and a dot will be here, and we're just going to go past them. We're going to type in 2, enter, and that line is done. So we can either close this or hit the escape button, and I just hit the escape button, and now we're going to highlight that line, and we're going to go to align selected objects. Under transform objects, click that, and we're going to click that center button, and now our line is in position right here. So we'll close that, and we are ready to turn it into a tool path. So what we're going to do is we're going to switch to tool path. So one of the things I want to warn you about right now, I've done many one-on-ones with people who are just getting into this, and they often are in the habit of, instead of switching from design mode, which is to your left, to the toolpath mode, which is on the right, by virtue of this switchover button right here, they use this tab, this pull-out tab right there. Now this is meant to be there for a temporary fix on something. I strongly recommend that you don't do this because you have two completely separate elements exposed at the same time. You have toolpath generation, or CAM, computer aided machining, and then you have CAD over on the other side, computer aided designing. They're two completely separate animals. So I'm going to strongly recommend that you do not use this tab up in this upper right corner, but rather use this blue arrow to switch out of the CAD side and into the CAM side. So I selected that button, and you see on this side there's another blue button there. You click that, that will take me back to the CAD side. So I'm going to go back to CAM, and you can see our line is selected. So what we're going to do is cut this on a profile. Now before we even run this tool path, we have to set the bit up in our tool library. Tslot cutters are set up a little bit different, and they're a little bit interesting. If you don't follow along with this and try to figure it out yourself, you'll probably get a little confused. So we're going to set that up right now, and you're going to learn how to set up T-cutters in your tool library. So let's go. So we're going to go to our bit library, which is this button right here, and it says below it display tool database. So select that, and there is our tool database. So one of the first things we want to do is set up our T-slot cutters. Now there's a little thing I want to show you that's going to make you question things, but once you understand this, you won't question it anymore. I'm going to just select an end mill here, any one, and you see it comes up with this field called tool type. And next to it is a pick box or drop down box, and inside it talks about all the different router bits, the different types, but there is no T-slot cutter. So we have to come up with an alternate plan to solve this, so we know that we're dealing with T-slots. We are going to treat a T-slot like an end mill. So I'm just clicking out of that because I don't want to mess with that one. What we're going to do is we're going to go up to the top field where it says Imperial Tools in inches. If you're in metrics, then you will go down the list until you get to your metrics tools down there, and you'll do the same thing. We'll select that, and we are going to hit the second button, and that says Add Group. So when we select that button, if you watch up here, it's going to give us a new group. I'm going to push it once, and now it's titled this new group and added that, and there's nothing in it. You see under end mills, there's a whole bunch of end mills here. Under new group, there's nothing, and it says new group. So we're going to simply come over into the name field and change that to Tslot Cutters. And then we're going to go down to the bottom and we're going to click the apply button. And now we have just changed the name to Tslot Cutter. So now we need to add a bit into it. So that's very easy. All we have to do is simply grab a bit from anywhere in here, and we are just going to select the 1/4 inch end mill. We're going to use those defaults, and we are going to come down to the bottom and duplicate that bit. So I'm going to select duplicate, and now it's just made a new one. What I'm going to do is simply drag that up under Tslot Cutter. I just click and drag, and now it's there. So we're going to start right off at the top and get this set up. First of all, we're going to change the name of it. So where it says end mill 1/4 inch, we know that our cutter is a 1/2 inch by a 1/4 inch. So it's a 1/2 inch wide by 1/4 inch wide. So in order to change this information, we need to select this little box right here. This will allow us to edit this text so we can change it to Tslot Cutter and what other information that we want it to say. So when you click it, you're going to get this dialog box, and we are going to change it. So basically we're just going to say it's a 1/2 inch Tslot Cutter, and what we want to do is, you see where it says unit short, we want to leave that alone. We are going to go outside of the diameter area, and where it says tool type, we're simply going to overwrite that. We're going to delete that in the brackets, and we're going to say T-slot. And we're going to say OK. And now it says Tslot 1/4 inch. So everything is perfect right now. But our T-slot is actually 1/2 inch. So you see where it says diameter here. We have a 1/4 inch. We're going to change that to 0.5. And click out of it. And now that number is changed to Tslot 1/2 inch. Number of flutes is 2. We're going to just click the copy button. What that's going to do is take that original 1/4 inch end mill data that we had, and it's going to punch it into this lower set of data fields. So we're going to change things around a little bit. The first thing is, how deep do we want this Tslot Cutter to go? Now remember, we have to actually dive down in and move across the project and then come back. Like here, we have to go down into the project, go across, and then come back again. So we have this kind of contour inside our project. If we were to take this and turn it upward like that and cut it in half right across there, or roughly there, we'll cut it right across there. This is what we're going to have. So that bit has to come down to here, to this level, the bottom of the slot, move across to some distance right over there, and come back again and come out. So we have to figure out what is this depth from here to here. Now with the bit that we are going to be using, it is like that, and this is the cutting edges. That is a 1/2 inch. So we're going to go 0.375. So what we have to do is fix the pass depth so that we get that 0.375 in one shot. So for this cutter, the pass depth is going to be 0.375. We want it to go to the full depth in one time. Now step over, we are not even going to be referencing step over on this, but I would set that at a 1% just to be on the safe side, because we won't be using that function. But if you accidentally have this bit selected, it'll only step over just a tiny bit and not cause any issues. Now the spindle speed for this bit is going to be 1600. or 1700. If you have a Makita router, then it will be approximately 3 on the dial. All right, so feeds in inches, we are in inches per minute. You would be in millimeters per second. I will provide that all this feed and speed data down below to have your thing set up, and we'll add that to the feeds and speeds tables in the next release. Okay, for feed rate, we are going to keep that turned down a bit. We are going to go to 30, and the only reason I'm keeping that down is because this is not a good cutter. So it's going to cut a little rough. Normally I'd probably cut it at about 60 inches per minute. And then the plunge rate, we want this to be a little low. So 10 is okay. I'm actually going to go a little shallower, a little slower, 8. And we are going to apply. Now, one of the things is I would put notes up in here. So when you're setting your bit up, you may want to just copy the Amazon link right into here that I provide down in the description box. Select apply. And okay, well, we don't have to do okay yet. We know we've got it up there in the Tslot cutter, and it is shown up as the Tslot cutter 1/2 inch. So we can select okay, and that bit is in there now. Well, you've just learned how to set up a Tslot cutter in your Vectric software. If this did not make sense to you, go back and watch this again. You have to set up Tslot cutters the right way. Otherwise, you will have problems on your projects when you try to cut them, especially when you're using the 2-stage Tslot cutters that'll cut both the slot and the little T-shape inside. Now, the feeds and speeds I showed you, they will be down in the description so that you can set yours up. I will make it both for inch and metric measurements from feeds and speeds. The other thing I just want to point out, this Tslot cutter that I'm showing you, and the link is going to be down in the description, it's a cheap bit. The problem is it's really hard to find a good 1/4 inch diameter 2-stage Tslot cutter that is reasonably priced for the 1/4 inch routers. They're either $10 for a set or over $100. So I'm actually going to find one for you. I'm talking to my supplier now and having them develop one because there's no middle of the road Tslot cutters out there. So keep your eyes out for that. I'll put it out in the next feeds and speeds charts when I get this bit taken care of. All right, so now we're going to get into the tool path. This is the fun part for you, where you can create the slot. But there are a couple things you have to know about the Vectric software when you're doing this, which you will learn in this segment. So yeah, let's just dive back into it and learn some more tricks. By the way, if you're getting something out of this, give me a thumbs up, please. And I want to hear a comment from you, especially if you have other ways of doing T-slots or if you just got some takeaways out of this. All right, let's go. So now we're going to actually cut our T-slot. So we will cut it on a profile cut. Very, very important. Do not use pocket, do not use Vcarve, do not use anything else but a profile cut. We want this bit to cut along the profile of that line and go back. So we select that profile cut, and our depth of cut is going to start at 0 and it's going to finish at the depth we want to go, which is 0.375. And we're going to change our bit by hitting the select button, and we are going to select the Tslot cutter and click select. That cutter is now set up. We want to make sure you are on the line. It won't work if you don't select on the line. As far as climb and conventional, these don't matter. It can be either one. Do not have your ramp turned on. This box must not be checked. And also, do not check add tabs. And then we're going to just change the name of this to Tslot. So we're going to say T-SLOT, and then we're going to say the name of the bit. So we're going to call this the 0.5, or we'll do a 1-2 TS. I'm going to call it TS for Tslot, and I'll use caps, TS. And we're going to say calculate. It's very easy. Now you get to see where the shortcoming of Vectric is. Vectric will not take into account that this is a T-shaped bit. So when we run it, which we're going to do right now, make sure the Tslot cut is selected, and we select the previous selected toolpath, and you can see now it just made a slot, but it did not make a T-slot. That's because Vectric does not work well in this type of 3D environment. We could probably get it to work if I did a couple other things, but we're not going to do that. Just know that this is okay, but we want to make sure that this is actually going to work right. So back over in your run area, you got this little slide bar. We're going to move the slide bar to the middle, reset the job, and then do it again. And you're actually going to see it cut across, but what we didn't see was it come back. So this is a shortcoming of Vectric. What I wanted to see was the bit would come down in. I'm going to actually run it again so you can see. So I'm going to slow it down some more, and we'll run it again. And now it's, so you saw that the bit started here, it ended here, but it didn't go back to here. This is a shortcoming in Vectric. But we're going to verify this in the G-code file. And this is where it's really important for you to make sure that you have this G-code file set up right. And we're going to run through that now. So first we're going to create the G-code file. We're going to select close, and then we are going to save this. So right now I am using a long mill CNC router, but I find that the Bob's CNC G-code generator post-processor works just fine, so that's what I'm using. It creates very basic G-code, so we have to select the toolpath, and we're going to save the toolpath. So we select Save Toolpath, and I'm just going to save it to my Downloads folder for right now, and I have the name of the bit. It is listed right there. It's Tslot 1-2S, so it's ½ inch S. So what I'm going to do is I'm just going to delete everything but Tslot, and I'm going to save it. Now we're going to open that up. So we're going to go to the directory where we saved that, and that should be in my Downloads folder, and there it is. Now you remember when I changed the name a little bit and I took out the 1-2TS? Well, that's because Vectric will automatically put your toolpath name into the directory. So if you have multiple toolpaths, always take out all the information except for what it is. So all I had left was Tslot, and it plugged in Tslot and the bit number or the name of the toolpath. So if you have multiple toolpaths, it'll create the G-code files for each toolpath with this extension name onto it. Now this has come in as the extension on this is G-code right there. Yours may come in as NC or TAP. You need to be able to open it up into a Word document so you can fix it appropriately if you need to. So what we're going to do is we are simply going to open this up in Notepad. Not a Word document, but Notepad. And this is what it looks like. So this is it. Very simple G-code. And it has very simple instructions up front right there. And then it tells me it's going into position. So it is now going to X-1. It's above the material, and it's going to feed down into the material at a point at 8 inches per minute, and then it's going to switch over to 30 inches per minute. It's going to cut across, and it's going to come back, and it's going to pull out right there. So this G-code works, and I'm going to show you that it works. Okay, we've finished our design. This video has taken a very long time relative to the actual amount of time it'll take you to design this up. Once you get good at it, it'll be wham bam, thank you ma'am. So now we're ready to cut our slot, but first we got to get the bit set up right in the machine. So I'm going to show you how to do that on my long mill CNC router. And by the way, if you are still trying to learn about CNC routers and want a really deep dive understanding of them, and get a review on a machine at the same time, the long mill, which is the one I endorse, there's a link down below for a review video that will educate you on what you should be looking for in a CNC router. Okay, we are going to get the Tslot cutter installed in the router, and I'm going to show you a very cool feature in the GCenter control software. So just so you know, GCenter is the software that actually runs your CNC router. So you have design software, you have the software that generates the tool paths, which Vectric does both, and then you have the control software that runs your machine. Now you can see on my screen right there, that's control software, and that's variant is called GCenter. I used to use Universal G-Code Sender, and I'm done with that. The GCenter is an open source freebie. And Longmill has it on their website. You can download it. And they have been working on it to make this really cool features. And I'm going to show you a really cool one using the touch plate, the probe, where you can set your zero with your bit. Really cool feature to keep you from breaking bits. So we're going to get into getting this bit set up right now. Let's go. I'm going to give you a couple of tips here that a lot of people don't get and ends up creating a lot of problems for them. So number one is whenever you change a bit in a router, you should take that nut off, pull the collet out, and blow out any sawdust that's in there. Now, I've already cleaned mine out, but the reason is because sawdust acts like a lubricant. So while your router is turning and it's making a cut over a long period of time, your router bit has a spiral to it for the most part, like down cuts or up cuts. And there's a force on that that's either up or down. If it's a up cut, it's trying to pull itself into the material. If it's a down cut, it's trying to push itself out. And over time, it will slide and move, and you will have uneven surfaces. So make sure you clean out that collet. Now, the second thing I want to point out is this is a Makita router, and it's got that little locking pin. That locking pin is here for one specific reason. It is here to hold your shaft from spinning while you're just getting the router bit in the router. This is not designed to take the force that you are going to be applying with your wrenches. I've seen too many people ask, why did this part of their router break? That's because they used a wrench. They used this, held the pin in, and then used a wrench to tighten the bit down, and that housing broke. This is aluminum. It's not strong enough to handle that. Okay, I can't stress that enough. Do not use this when you're tightening your bit. You're only going to use it while you're setting your bit in there. So I am putting the nut on, and I'm going to set the bit in about halfway, maybe a little bit more. And I'm holding the pin down, and I'm going to turn the nut, because if I don't hold the bit, it's just going to slide. So I'll just hold it like that. I'll turn the nut and snug it until the bit won't move. This is why you have two wrenches, not this pin right here. And that's why you have the slot on your shaft. And we will give it a good snug. There we go. You don't need to over tighten. Okay, well, there we have it. I can't stress this enough. Do not use that red pin as part of your wrenching to tightening down your bit. You will break your router. Use both wrenches. All right, so what we're going to be doing now is we are going to set this bit using the touch probe on the Longmill, what they send with their machine. And we're going to be doing it with the GCenter software. Now, you're going to learn a lot of features about the GCenter control software here, so you want to stick around. You're getting a lot more than just Tslot in this video. So what we're going to do is just get in there and zero out this bit, and I'm going to show you exactly how to do it. And it's so easy once you get the hang of it. Let's go. Now, in this case, we are going to use a center mark for our slot, and we're going to cut that way. Just a word of wisdom for you: try to make your slots with the grain of the wood as opposed to across the grain. It just cuts much easier that way. So I have a Longmill CNC router, and I'll tell you what I really like is the G-Code Sender has got a built-in feature for their touch probe. And if you ever get your CNC router, make sure you get a touch probe with it. The one with the Longmill and the gSender software make it super, super easy. So what we're going to do here is set our zero. We're going to use the touch probe to set the Z0 on the surface here, and the software knows to compensate for the thickness of this plate. Now, here's one of the cool features of the gSender software. It will not allow this to run without making sure that everything is hooked up properly. This bit will come down and touch this material and we'll close the switch. Basically, you'll have electrical conductivity that goes through there. It tells the machine control that it is at 0. But you can only get that if you attach your probe to the other end of the bit. So let's go ahead and set this up. What we're going to do is we're going to bring this over to somewhere over around this position here. We're just going to set up that 0 real quick, and then we're going to set our X and Y 0. So what we're going to do is we're going to jog the bit down relatively close to the touch plate, maybe about 10 millimeters above or a ½ inch above, somewhere like that. But I'm going to set the touch plate off to the side. We're not going to have the magnet on there at the moment, and just want to eyeball it to get it relatively close. So it'll be out of the way. Okay, so now we are going to get into the control software, the software that runs your CNC router. It's called gSender. Now, gSender is something that you have to have with your CNC router, or the control software. I just happen to be using gSender, which I totally recommend as well. gSender is the most newest, most robust, most up-to-date, and has the most features relative to all the other ones. As I said, it's a free download that you can get off the Longmill CNC website. They are actively working on it. So you're getting the most up-to-date control software, and it's so easily laid out. But I am creating this video as if you are still really new to this. So I'm going to introduce you to the gSender software as an overview, and then we'll get into getting this router positioned the way we want to with the Tslot Cutter bit. So let's get into the gSender software and learn some more stuff. Hope you're getting something out of this. All right. Go get a cup of coffee. We got a little while to go yet. All right, let's go. Okay, so now we have to get into the gSender software. This is the software that actually controls your CNC router. And gSender, just so you know, is an open source software that Longmill has taken and worked with the gSender programmers to add a lot of features to this that no other control software has. But for now, we're just going to deal with the probe section, and we're going to deal with the manual motion section, and we're going to deal with setting up 0 points, and then we're going to deal with loading up a program over here. So I do want to give you a quick rundown if you've never used it before. This is a very easy to use platform. You have probably heard a lot about something called Universal G-Code Center. gSender is the same thing, but it works very differently and is much more robust. And by the way, this is free, and you can get this version that has had a lot of tweaks done to it by Longmill from their website for free. All right, so let's kind of talk about what you're looking at here. I will do another video that deep dives into this. This area over here is the display area where you can actually see what your router is supposed to be doing. And then over in this area it tells you your X, Y, and Z positions, and is where you set your 0 values right here, here, and here. Down below that is the jog control. Now the jog control allows you to manually move the machine around the way you want to. And so you have quite a few different buttons. You've got the Y plus and minus buttons. So just so you know, Y minus is always toward you. That is considered the front of the machine. Y plus is away from you. X plus is to your right and X minus is to your left. Z is up and down. Z plus is up. Z minus is down. And then you'll see a couple other arrow buttons around the side. That allows you to move it diagonally in the XY directions respective to the buttons that are on either side. And then you've got some speed controls over here where this will allow or control the jog distance. You'll understand that in a little bit. And then down here are some other controls where you can run your probe, you can enter manual data, you can insert macros, that's a little bit more advanced, and then there's other features as well. gSender has a lot of features, but I just want you to get the layout here. So what we're going to do is we are going to move the bit down closer, and the way we're going to do that is by hitting the Z down button. First of all, we want to set up our displacement, or how far it's going to move. You see there's 3 buttons over here. The top one says rapid, the middle one says normal, and the bottom one says precise. Now, basically what that means is the rapid is it's moving a long distance. It should probably be reworded to long jog and medium jog and short jog. So when you select a button, you were just telling the software that whatever is set in this fields down below, that's the distance it's going to move. So rapid is actually a longer distance. And right now, so 1 on the X and Y. So if I click any of these buttons here, it's going to move 1 in the X and Y direction, or X or Y direction. If you press an arrow, it'll move 1 in the X and 1 in the Y at the same time. For the Z, it's usually a lower value, and in this case it's 1/2 of an inch. So if I click this button right now, the Z will move down by 1/2 of an inch. And we're going to click this right now to get this to move down closer to the material. So you see we got a bit of a move out of that, and this Z plunge is set at 1/2 inch in the rapid mode, and I know I have more than 1/2 of an inch. Now 1/2 inch is about 13 millimeters. So we're going to hit that button one more time. And now we are relatively close. I want to get a little bit closer. But this time we don't want it to go down by 1/2 of an inch. So we are going to go from our long jog or our rapid button, and we're going to go down to our normal or medium jog. That changes our movement for each time we push the button to a 0.04 inch. So we can nudge it down. And we're going to do it a couple times until we get to a distance that we like. So we are currently maybe 1/2 of an inch. So that's good for me. So now we're going to set up to probe the Z height. In the GCenter software, the probing sequence will be down in the lower right corner. Now this box has several tabs on it. You want to make sure you have the probe tab highlighted, and there's a picture of an end mill and a box there. Since we are doing the Z height, we want to do the Z touch only. When I select this box, you can see there's several selections. I'll cover this in a more in-depth video on GCenter itself. When you're all set up, all you have to do is press the probe button. However, one of the things that people often forget to do is to set up their other contact surface. And it will start the probe sequence, and a bit will come down and it'll keep driving into the material until the machine can't push it anymore, or it'll break the bit, it'll damage the touch plate. So what the boys at Long Mill did was make a change to the program that's really cool. It actually forces you to make sure that this is connected. So what they did was add a little routine at the front of the zero setting touch sequence that forces you to make sure that a complete circuit can be made. So when you press probe, you're going to get this dialog box up, and it says ensure the tool is positioned as shown, and to confirm a reliable circuit, touch your plate to the tool. So basically what you need to do is pick your plate up and touch it to the bit. If there's a complete circuit, this light will turn green, and this button will allow you to click it, starting the zeroing sequence. That means that if I did not have this connected and I touched it, it's not going to register in the software and will not let me continue. That means I have to have this connected, and I have to actually grab the plate and bring it up to the bit. And when I actually touch it, the red light will turn green while I'm touching it, and the start probe sequence will highlight. So now I can start that sequence. Right now I'm still holding the thing to the probe. When I let it go, that turns red, but we have confirmed that we are good to go, and we can now press this button to start our zeroing sequence. And the probe starts to move down. Now you see it's going to touch, and then it's going to come down again at a slower speed. And now we're all set up. We can remove the touch plate and the magnet and just set it aside. And in order to set our X and Y, we are simply going to nudge this down close to the material and generally eyeball the center here. This is not critical because we're making a slot back and forth, and there's somewhere in that slot is going to be your balance point for your picture. So it's a simple jogging of the bit to the right, a little bit forward, so we can eyeball over that plus. So I'm pretty comfortable in the Y, not quite yet. It's got to move a little bit more. Nope, I went too far. And there we are. Now that our CNC router bit is probed to the top of the surface of the material and we have positioned our X and Y where we want it, we simply have to set X and Y in the software. So you can see right now it says that X is about 0.24 from wherever it's being referenced at, and Y is about a 0.22. But we know that the bit is right over the position that we want it to be in. So all we have to do is just select the button that says X0, and we click it and it'll turn this number to 0. Same thing with Y, Y0, we click it and it turns to 0. Now you notice a little minus button popped up there, minus sign. I don't know what that means or why. It doesn't really matter. We're still at 0. Now our bit is set, and it's time to upload the program that's going to cut the T-slot. We come over to this blue button in the display screen that says load file. So you click that button and your file is going to, your directories are going to open up, and you select the file that you want. So this is the Tslot G code, so we select that and now it is in the file and we are basically ready to go. All we have to do is turn the router on and make sure your project is clamped down appropriately and hit the start button right here. And that is it. There is our T-slot. So the bit didn't do so bad. It just won't last a long time. But the good thing about these bits is they don't get used that much. So maybe the cheap one is worth getting. And now, my friend, you know how to create a T-slot. So you can make signs and hang them on the wall. You also know where to get the Tslot cutters, links are down below, and how to set them up in your tool library. So important. And you have access to the G code now, so you don't even have to go and design it yourself. I'm just giving it to you. Again, you are responsible for that. Make sure you follow the instructions and you will do just fine. Now, you learned a lot about the GCenter software as well. Kind of a bonus here. I want to make sure you know that GCenter is not locked to the long mill. It works for virtually any CNC router that uses what they call the Arduino platform. Your CNC router works on the Arduino, don't worry about it. But if you're looking for CNC routers, you're not really sure what to be looking for, then you want to watch that review that I made about this thing. You know, the one I was riding on the machine while it was running, because it was built to educate you on CNC routers and to help you know what to be looking for. So that link is down below as well. And with all that being said, go check out all the rest of the links down there, and I hope you have a great day, better tomorrow, and that you got something out of this. Give me a thumbs up if you did, and a comment if you know of another way of doing T-slots. I'm Garrett with IDC Woodcraft, and I'll talk to you next time.